jelly bean.
Okay. Good morning.
Good morning.
Good morning.
So, we're going to do an activity today that is not part of the normal curriculum. We didn't even do it in the spring, in the fall. But we have, I think, one extra day in the spring, but we don't have it in the fall. So we decided to do something kind of fun and maybe teach you something new. But before we do that, we got a test to go over. So there you go. As we all know, you get the test back and Dr. White loses everyone's attention, so we'll go over the test first, and then you'll get to see how you do. Okay, some will go over pretty quickly, others will go over a little slower and a bit more detail. Okay, so, I was hoping that people would not forget about writing equilibrium expressions. Unfortunately, some people did. I'm going to ask everyone to close laptops. And hopefully you will start to, you have already started preparing for the final as well as the polyatomic naming quiz, which will be a week from today. Okay. Let's start with the all right, so equilibrium expression for 1A, volunteers. That's it.
MH3 in the bracket
Give me
concentration.
the entire thing that would get you the full point.
Oh, KEQ
Thank
equals MH3, the concentration brackets, to the fourth power, O2 concentration to the fifth power over the reactants, which is H2O, brackets for the concentration to the sixth power, NO, brackets for the concentration, fourth power.
Yes, multiply. Actually, I'm going to put this class or the other, so I'm going to actually put a plus sign in it. Okay. Also, more people than you get on the quiz fail to include the KEQ equals. That was a quarter-point deduction in both cases. Okay, how about B? Huge?
Since the rod is a solid, it's just one
Yes.
over the concentration of OH minus cubed times the concentration of Fe3. There is a
There's a coefficient, so just the concentration of Fe3 plus. Okay. All right, I think there might have been an example of someone who left off the charges, which is also another. OH without the charge does not exist in iron 3 or iron without the +3 charge is a solid. Okay, question 2. For the reaction N2 gas plus 3 moles of hydrogen gas going to form 2 moles of ammonia and releasing heat. Will the equilibrium shift to the right, the left, or will there be no shift with the following disturbances? A, removing ammonia. Eunice.
We'll shift to the right of the product.
For NH3?
For removing.
Removing NH3, I'm sorry, I didn't pay attention to my own words there. Correct, so if you remove the product, the reaction will shift to form more. Okay, how about if you increase the temperature? Somebody other than the 3 surrounding.
To the left.
It's going to shift to the left, to the reactant side. And finally, if you decrease the pressure by increasing the volume of the container, the shift is going to be, it's going to shift to the left as well. You've got 4 moles of reactants to only 2 moles of product. So it's going to shift to compensate for the increase in space by making 1 mole of gas. Okay, question 3. For the reaction NH3, 4NH3 plus 3O2, forming 6 moles of water and 2 moles of nitrogen gas. If the value of KEQ is very large at a certain temperature, are the products or the reactants favored under these conditions, and I want you to explain your answer. First,
The products should be favored.
Because?
Because if the KEQ is very large, it means that the numerator is much larger than the denominator. Although I feel like if the values of the moles are like very large, then I need 6 power. So I feel like it is actually very large.
Well, if there's very little of it.
Yeah, but
Even
if
to
there's
the
very
6
little.
power, you need 6 power.
If there's very little, then it should
Okay, so remember, KEQ is the ratio of the products to the reactants. So if KEQ is very large, then the amount of reactants compared to your products compared to your reactants is going to be large.
You mean by favored?
Meaning how much, which of them is there more of? Any questions from this first page? Oh, there's one more on this page. Okay, so if KQ for the reaction 2A plus 2B going to form 4C plus 2D is 1.5 at a certain temperature, what is the KEQ for the reaction 2C plus D going to form A plus B? Joey?
1 over 1.5.
1 over 1.5? It is not 1 over 1.5.
It's 1 over the square root of 1.5.
It is 1 over the square root of 1.5. Okay. Because not only have we reversed the reaction, which is why we do the 1 over 1.5, but we also basically cut the amount of material in half in a equation that requires taking the square root of our equilibrium constant. Okay, questions about that one or anything else on the first one? Question for part 1 for the equilibrium system 3C plus D going to 2A plus B. If you were to calculate KEQ when the equilibrium concentrations are 0.45 for both A and B and 0.275 for both C and D. Okay. don't have the calculation in front of you, so you don't have to give me the value, but setting this up, what would you do? On 1x. MA?
You could do QQ equals 0.450 and like the bracket squared
Okay.
times 0.450 in the bracket squared because that's the constitutions of A and B during your products, and then you would divide that by, or it would be that over 0.275 to the third times 0.275 to the third.
Okay. Is that 4.450 cubed over 0.275 to the fourth? Doing the math will give you a KEQ value of 15.9. Okay. Okay, moving on to part 2. You were given concentration concentration, and you were to calculate pH, POH, and concentration of the other ion from water. So 0.050, to get the POH, you would simply do what? Okay, that gives you your POH. Then to get the pH, you do what?
14 minus that.
And what's that? 14 minus that value. So taking the pH of 0.0500 gives you 1.30. Subtracting that value from 14 gives you a pH of 12.70. And then to get the concentration of H plus ions, you would
Do 10 to the negative.
do 10 to the negative 12.70, which gives you approximately 2 times 10 to the minus 13 molar. Remember, all concentrations are in molarity. And I did take off if you did not write molar.
Doesn't that have like the brackets around it? So,
That means it's molarity.
yeah, but like, isn't it kind of it's like when we do the calculation.
KQ, there is a unit associated with KQ. It varies depending on the whatever, which is why we don't report it. But the concentration is always more. So a solution that has an H plus concentration of 4.3 times 10 to the minus 4. To get the pH of that, we again simply take a negative 1. And again, to get the POH, that value is 3.367. To get the POH, we would then 14 minus that, which is 10.633. And the concentration of OH minus in this case would be 2.33 times 10 to the negative 11 again, mole. Okay, like this question. If Ka of weak acid A is 4.3 times 10 to the minus 4, and shouldn't say the, and the Ka of weak acid B is 6.7 times 10 to the minus 6, which acid, A or B, will have a lower pH if the acids have the same concentration? And again, you want to explain your answer. So, which of the two acids would have the lower pH?
Acid A would have the lower pH because the Ka value of acid A is greater than the Ka value of acid B, meaning that there is more products formed, and the products where the concentration of hydrogen ions are. So if there's more hydrogen ions, then there's lower pH.
Absolutely. Okay. If that makes sense to everyone. Anyone who didn't get it? Very good. Moving on to part 3, equilibrium constants. You were to write the equilibrium reaction for the ionization of benzoic acid, which is the formula C7H5O2H. What does the equilibrium reaction for that ionization look like?
Are the products H plus and C7H5?
They are. All acids ionize in a similar fashion. Simply, that's what we define an acid as. Something that gives up hydrogen ions in solution. Okay? For most acids, it's simply 1. There's some acids that give up 2 hydrogen ions, like sulfuric, and then there are even some that give up 3, like phosphoric. Okay? But the equilibrium reaction would simply be C7H5O2H, equilibrium arrow, C7H5O2 minus plus H plus. And so the KEQ, the equilibrium expression, would be maybe I should start calling on people since I get the same hands that are volunteer. Now it should look like you want to raise your hand. What is the equilibrium expression for that ionization of that? And if the pH of the solution, which is 0.2 molar, is 2.45, then how would we go about, bless you, figuring out what Ka is equal to? Here's another,
For the first part, you can set pH equal to -1. Or
this gives you 3.55 times 3 minus 3 molar. And so, what then do we do here? out with our reactant, and that reactant decomposes or ionizes to form our products, the amount of products that we form is going to cause a decrease in the amount of the reactant that we started out with. So you need to include that part into your equation. And then solving. Something on the order of 6.42 becomes 10 to the minus 5. Questions about this one? Okay, so we were given the reaction of hydrogen gas plus nitrogen gas forms ammonia again, and it gives you the initial concentrations for all three of the substances. It then tells you that when the system reaches equilibrium, the concentration of H2 gas is increased to 0.650, and it wants you to complete the table and then solve for KEQ. Okay, so it shows you that H2 is added 0.150 molar solution to become 0.650 molar. How would we go about solving for N2 and NH3? Okay. Vincent, what would be the change for N2?
So you know that the change for H2 is based on the molar ratio, which is based on the balance equation. So you know that 0.15 molarity for the H2 is actually equivalent of 3x, if we're saying x is the change. Then that would mean that 0.150 molarity divided by 3 is equivalent to x, which would be your N2 because that only has 1 mole. So I don't know what that division is, 0.050 molarity.
That is correct.
And then the NH3.
Pass that one on to someone else.
It would be 0.150 times 2/3. Be 0.10. The ratio of NH3 to H2 is 2/3. So it would be subtracting the 5 rather than the
Okay. Say that one more time.
So like the ratio of like NH3 to H2 is 2 to 3 neutrons. So for every
Okay, so you took the 0.15, multiply that by 2/3.
yeah, and you subtract it from the initial NH3.
Okay, so that means our equilibrium concentrations for, what about the signs? So for N2,
That's
That-
added.
what's that?
N2, the change is additional because it's on the reactant side.
Okay.
And it's with the H2. giving it
Okay.
more.
Absolutely. So whatever happens to one reactant happens at the same, not necessarily the same magnitude, but in the same direction as the other reaction. So for N2 it's plus, and for NH3 it's minus. Yes. Okay. So at equilibrium, the concentration of N2 would be 0.350 molar, and NH3 would be 1.10 molar, okay? Because that one is being subtracted. Well, if you plug those values into your KEQ calculation, you should get a value of 12.6. Okay. 1.10 squared divided by 0.650 cubed times 0.35 gives you 12.6. Okay. I want to know what the concentration of a 25 ml sample of calcium hydroxide, if the sample requires 40 milliliters of 0.3 molar HBr to neutralize. Okay. What would make sense to be the first step in solving this problem? Providing a balanced equation. Absolutely. balanced equation for this one would be, so HBr and calcium hydroxide. There you go.
So it's HBr plus CaOH2.
Goes to form
H2O plus Br2.
Yes. Balanced?
So 2 in front of the HBr and 2 in front of the H2O.
Balanced. And so, to then figure out what the concentration is of the sample,
We go through this equation. So, 40 milliliters of 0 times 1 liter over 1,000 milliliters.
or you can simply
Oh yeah. Then times 0.3. Times 1 mole of sodium H2 hydroxide or 2 moles of hydrogen HBr. And then, well, we have that just using the base. Divide by,
math. And 240. And that's calcium hydroxide. Okay. So she's still counting. I was actually quite pleased that the number of people that worked with number 2 correctly. Most of the class correctly did question. So you were to calculate the mass percent of acetic acid in a vinegar sample. If 17.5 grams of vinegar required 33.95 milliliters of sodium hydroxide. Very similar process to problem 1. This time, instead of using HBr and calcium hydroxide, now you're using acetic acid and sodium hydroxide. Okay? And instead of starting with 40 mils, you're starting with 33.95, and you're calculating the number of grams of acetic acid. Okay? So instead of this step, once you hit moles of your acetic acid, you simply multiply that by the molar mass of acetic acid, 60.06, and you should have calculated a mass of 1.020 grams acetic acid. Simply divide that by the 17.5 grams of vinegar and multiply by 100%, and you get 5.83%. Okay. Hydrochloric acid is a strong acid. Hydrochloric acid is a weak acid. You were to identify the intermolecular forces of each of those acids, and then use your understanding of intermolecular force to provide an explanation for the difference in the acids. Okay, so this was kind of one of those take what you know and apply it to something slightly different. First off, the intermolecular force associated with hydrochloric acid is dipole-dipole. For hydrofluoric acid, it is hydrogen bonding. And so, what do we know about hydrogen bonding and dipole-dipole that made hydrofluoric acid strong, but hydrofluoric acid weak?
Hydrogen bonding is stronger bond than the they don't like fall apart, I guess.
Takes a lot more energy to break them, which is why water is such a small molecule, but it takes a lot of energy to convert it to steam. Okay? And
And dipole, it's easier to take away hydrogen ions. Like hydrochloric acid is strong because the way that hydrofluoric acid.
very good. Everyone get that? Absolutely. So, stronger the intermolecular forces is, the harder it is to break them up, and therefore the less likelihood of hydrogen ions being released. Nitric acid is also a strong acid. You were asked to draw the Lewis structure. Practice session on drawing Lewis structures. What is the process?
The central atom.
What do you do to come up with a Lewis structure? Zoe?
You draw the central atom first.
Okay, even before that, what's the find the number of valence electrons. So for hydrogen, it's 1. For nitrogen, it's and for each oxygen, it's 6 times 3, 18, for a total of 24. So your Lewis structure should represent the 24 valence electrons. And then, what is our central atom?
Nitrogen.
Nitrogen. And the hint was given to you that the hydrogen is bonded to one of the oxygens, not to the central atom. And so our next move would be
And oxygen on each side.
and at that point we can go ahead and put our hydrogen in because we know that it's bonded to one of them. Our next step would then be
You need a 2 double bonds. You need a 1 double bond.
but before we even get to that, what should we do next?
Draw the lone pairs on the all the oxygen.
Exactly. So we want to complete the octet for everything except our central atom. Okay. Hydrogen's got its 1 bond, it's nice and happy. This oxygen has 4 electrons, meaning that it needs 2 more. 4 more. 2 more pairs. And then our other 2 oxygens each need 6 electrons to complete their octets. And then doing a count, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. We've used up all of our electrons. But our problem is nitrogen only has 6, prefers to have 8. So at that point, we do what? We put in our double check. So that would be our Lewis structure. And then what would be the geometry around our nitrogen? Emily. Very good. Question 5, which of the 5 reaction types is the reaction between nitric acid and sodium hydroxide? Double displacement. Okay. We have 2 ionic compounds or an ionic compound and an acid. It's always going to be double displacement. Okay, and then we came to question 6, the last page. HBr and calcium hydroxide. Okay. I was hoping for some of you the light little bit on. Oh, let me go back to the previous question and make sure I got the structure for calcium hydroxide correct. Some people didn't do that. Okay. But our balanced equation, we've already done. And this was basically helping you to step through. In previous years, we just gave you the question and asked you for the pH. Okay? Freaked some students out. Totally. And so we decided to do it stepwise, and unfortunately, it's still freaks some students out. Okay? Most people did okay until the very end. Some people kind of got lost at the beginning. So, first question is, what is the total volume of the new solution formed by this combination? You just added the milliliters of each of the 2 reactants. 20 mils plus 30 mils equals 50 mils. And unfortunately, because it said on the first page to show all work, whoever wrote just 50 milliliters and did not show how they got 50 milliliters, got a half of it. It then asks you how many moles of each of the reactants do you have? And how would you go about figuring that out? Or how would you figure out the number of moles of each reactant you have in this reaction?
Multiply the milliliters you have by the molarity, as in by the amount of moles per liter, in this case 1,000 milliliters.
So you get 0.150 moles of HBr. You do the same thing with calcium hydroxide. Behold, you get the same number of moles. Okay, so 0.015 moles of HBr, 0.015 moles of calcium hydroxide. It then asks you which of the reactants is the limiting reactant and which one is the excess.
That was the question. So on the intermediate, especially, do you still need to keep in mind under 60 days after?
You should. Which is where this one came from, and I failed to 4 here, 3 here, so our answer should have 13. Question or answer?
Answer.
Okay.
So looking at the coefficients,
Uh-huh.
H squared is going to be limiting.
Okay.
The 2 moles of whatever it was.
Absolutely. Okay. And this one you could have looked at and kind of done in your head. Okay. So for this one, if you just said HBr was limiting, calcium hydroxide was excess, you got full credit. Okay. Because based on our balanced equation, for every 1 calcium hydroxide, we need 2 HBr. Okay. So with that 0.015 moles of HBr, we would only need 0.0075 moles of the calcium hydroxide. But we have 0.0150. So that is our excess reagent. And then it asks you how many moles of excess reactant remain. As I just said, with the 0.05 moles of HBr, we only need 0.0. This is what we have. This is all we need. Which means .00750 moles of calcium hydroxide are in excess. Okay, everyone follow along with the logic as well as with the math. And then ask you, what is the molarity of the excess reactant? So what do you need to do here?
I think it's, you have the 0.015 moles of the CaOH2, but now it's in 50 milliliters of solution.
Do you have 0.015 moles?
Or in the solution before the reaction.
You have excess reactions already taking place.
And then you use the 0.075 and then you have the 50 milliliters.
So half of that calcium hydroxide is now water and calcium chloride. So you have to use what you have left. And then, so now you've gone from 30 mils to a total of 50 mils. So you now have to divide by your 50 mils of solution. Which gives you 0.015 molar calcium hydroxide. And finally, it asks you what is the pH of this solution.
Was that him playing the negative log of that? Of that differential?
What's in?
The 14 minus the negative log of, what do you count that out?
Because for each mole of CaOH, you create 2 moles of H minus. So that would be 0.03 molar. So negative log of the
Yeah, 0.1015. That means you get 0.03. And you have to take the negative log of the 0.03.
and then you can make it work.
And then 14 minus. Actually, my molarity is off. Okay, so if in fact you took this concentration and determined the pOH of that, and then took 14 minus that, gives you the pH of your solution, you received one of the 2 points. But if you in fact realize that for every 1 mole of that, you get 2 moles of hydroxide, took that value, determined the pOH, subtracted it from 14, and got the pH, then you receive the correct. Okay, any questions? All right, let's take a look at
I feel like we should have done that before going over.
Is that a high five joke?
I don't know what this is about.
What is it out of?
It's out of 40.
If you got more than 20, then you're doing a good job, Jack. High five?
Maybe more of a shrug.
I'll be back.
How was physics yesterday? With the posters?
It wasn't that hard.
It was great. I loved it. Did he collect them?
Not really. You can choose to like let him keep
Did you get number 5?
Yeah.
Oh, that number 5? There are like a bajillion number 5s. Like that one. Did you get part A number 2?
Yeah.
out of body parts, right?
Yeah. Oh my god. Did you not do the exercise? Or I put .305. And I added instead of subtracted at one point. Did you by any chance do like 3-1 correctly?
Yeah. I accidentally put C to H5O2.
How did you get like these numbers?
I worked it. I did that to that, and I just
Okay. Do you want this?
Okay, any questions?
You don't have a double bond. That's what I wrote. Yeah, this one only had 6 around it.
Typically, my policy is if I can't read it, it's wrong.
This one? It just is this way.
All right, anything else?
Did you put gel in your hair, or is it naturally curly?
Yes. I don't have gel.
Oh. Do you know how some people put, like...
Yeah.
But if I shower at night and my hair goes everywhere, it's just like, that's great. That's
cute.
nice. Thank you. My hair used to be as straight as you are. And then I grew up, and now it's not.
My hair used to be really curly. Why is everyone getting out early bit ups? What? You see all those people? They're all getting out early. That's because this is a double knot. They probably have a single knot. Oh. So did you learn a lot about like scientists, or was it just kind of like whatever?
Everybody else's was whatever, but we had the best one.
Yeah, ours was pretty great. Whose was yours?
Richard Feynman.
Who?
He's the heckin' coolest person ever.
What did he do?
He taught physics classes in strip clubs, for one.
Like and then they became physicists?
Yeah, and he was super smart. He came up with this theory and everything. He worked on the Manhattan Project and really liked to mess with people. He stole secret government documents and left behind post-it notes that said, "Guess who?" It was hilarious.
Did he get killed?
No, but they sure tried.
Wait, what?
Remember the FBI was like, "Oh my god, this guy's dangerous. We should probably kill him."
I don't remember that.
It's gonna be in the book eventually. Actually, it might. I've read it in a document
He
online.
actually like almost get killed.
No, they never actually like took action because the government was like, "Wait a second, that's kind of extreme. He's a chill dude."
I probably would have killed him. He stole government documents. That's a little off. He didn't steal them. I thought he something out and said.
Yeah, but no, he like took the documents out and left the note.
Where do you put the documents?
He eventually gave it back. He was like, thanks for letting me borrow it.
Yeah.
Oh, I just thought he put it out and say.
Nah.
He kept getting bigger and better face.
He was like, "Oh, doesn't change how."
So he was an evil scientist.
No, he was a good dude.
He was just quirky.
What's the name? Oh, duh. Oh, At what?
She gave you a half point.
For what?
60.
For what part?
60.
For what part?
The last one.
Yeah.
That was the better one. Do you guys know what colleges you want to go to?
I did, and then I came to INSA.
What did you want to go to?
Caltech or MIT.
I heard Caltech is full of like weird people though.
Exactly, that's where Richard Feynman went. Thank you.
You can keep that?
Yep.
So where do you want to go? Like you don't want to go to either of those places anymore?
No, after coming to INSA, I started to not love science anymore.
So what do you love now?
Nothing. Not science. That's the INSA
Wait,
effect.
but you know what? Like you could become a scientist and like make new tea flavors. Like if that's your passion. What?
God, I wish she graded on the quiz.
But then there's always one kid that gets 100%.
Not this time. This time the highest score was 37.5.
What was the average?
Once you find the average, we can find the lowest score. No, wait, that's true.
You find what is that? You need to find the lowest score.
Yeah.
Is that a lab?
Can you give us the range?
Is this a lab?
Justice and Martin.
Oh, is this the mole one?
About guess.
Dr. White, are we going to get the one where we make a mole?
That's actually, my son, give students extra credit, but now we've replaced it with the
Oh, so we could have made a mold, but now we have a test? Gee, thanks for replacing that. Not better. I'm sorry. I want to make a mold.
Okay, so, we talked about gases, we talked about, a couple different of our units and how important they play a role in reactions. And now we're going to look specifically at gases and kind of in a bit of a fun way. You are going to go around to the 5 stations, excuse me, and you can just write your observations on here. And then because we probably will not have time to talk about it today, but on Thursday, we will kind of talk about what it all means. Okay? Basically, there are a number of properties that determine the amount of gas that is present in a reaction system. Okay? And we're going to explore some of those relationships today. Okay? So at these stations, you are going to be blowing up balloons, playing with whoopee cushions, blowing up balloons in a different way, crushing aluminum cans, and shooting potatoes.
Wait, like blowing them up?
Well, in one case you'll be physically blowing them up, manually blowing them up, and in the second way you'll be creating gas to blow them. Okay. So the directions for each of the stations is on the table. You just want to follow along and then pay close attention to what you're doing. Note what is changing. Okay. So for each station that you visit, you want to write down the station number, and you want to pay attention to specifically what you are changing and what the result of that change is. Okay? And from there, we're going to develop some gas laws. Okay? So we're going to better understand the relationship of physical properties as they relate to gases. Okay? So let's just quickly go into the lab. I will explain each station, and then you guys are free to
Coffee. Do you have any photos?
but it does demonstrate
Sick kicks, bro. Those must be the new glory. Don't you know those are the female within these things?
That's what's fixed.
I think those are the emptiest bottles I've ever seen.
Oh, I know it.
What do you do in fifth month? Huh?
What?
I still give you, live up to your end of the deal.
For what?
I did a deal yesterday, you do something for me, I did something. Give him the speaker, he loves it.
And what?
Budget pressure.
What was the deal?
Don't know, pressure.
Right now. What?
Temperature, wait, no, it's a relationship of temperature, volume, pressure. Wait, actually, and give him too.
I don't want it, but I heard it. It has something to do with Amit's bed.
No.
No.
I was just no, but I wish you could read it in my fast and
Oh.
No, it's only one conversation.
One conversation will give you a lot of.
Nobody read my comment.
that's another person. Now you just.
Is this the?
Why are you doing it in the
Wait.
You told her this?
No.
I just thought you were doing that.
That was.
Because you were working on the
She asked me questions to answer.
Yeah.
And I was trying to, Ari,
Are you with it now?
I think I'm going to be. Yeah,
I have to get
all I wanted to do was write my own paper. I had 3.5 pages written by the time I got 50 mine. And I had to write 7 by.
Do you finish?
That's how much.
Like an hour and a half left to spare. Plus revision, I finished with your fun. Maybe an hour and a half left.
I made a lot of shit.
Do you want to do that?
I gotta see.
Yeah, it was because of the Celtics game. It was Celtics starters.
30 and 75.
I got one.
Above or below?
Wow.
That's not.
It's between 29 and 31. I'm guessing it's like 13 points. I'm just looking at silly things. Plus side instead of multiplication.
Now I gotta study for.
I got it.
Yes, 10 points flat or 10.
Wait, are you doing this?
10 points. I want one.
Yeah. Okay. Five.
I let go of my lip.
Well, if you think of it in terms of, you got a 30.5.
I thought you were going to start last
So
Friday.
I did.
that's on each. I really need that.
No,
Yeah, next one, next one.
sorry.
Here. Study.
Wait for one.
Back. Where's the apologies on my guy?
Wait for one more, yeah.
Negative, just appeared at the table. Oh wait, it's right next to it.
Look at
That's
that.
strong, that's good.
I'm not done my square.
She's a senator. Why is he the only class that said?
What's your face has senators? What? Sex with an M.
Pickle.
Mad. Yeah. I don't have that. It's the best t-shirt ever, man.
You're voting for St. Allen.
It's the reason why I know how to semi-write. Or how I know how when I'm writing badly.
I'm probably
Oh,
Henry Lamar was one of them. Chapter 7, 8 pages.
8 pages.
That's actually dumb as hell.
I think someone's doing that. They just weird. You just didn't read the right side of poems. Which better ones? Like which one? Which is start? You can have a picture of that. Okay, so who's second objects? Doesn't matter. I don't need the chest anymore. Where are you? I'm on my own road. Wait, I thought if you wake up, you get. Well, no. No. Oh, that's only fine.
I just want to where's my, I kind of messed up when I'm not saying okay or whatever. Very long.
Because remember that freaking screwed up. I thought he had an E or a vowel next to it, then I had to put the apostrophe. So I got a 13 out of 20. And I got 100 because I knew what it was wrong. Okay. So I'm back. Now I don't have to worry about someone saying, you're not worried about having his Ellie.
Are those summaries Hamilton again?
Yeah, those are the three.
Submarines, hey, do you have
I'm scared, but I'm just down there.
no meat? Sorry. Oh. Wait, what's our submarine? No, I think ours will be big.
I thought you were reading.
It's so sad. Freaking that scares me.
No,
Oh my god, I spent the whole night reading that book. I didn't read it because I didn't get excited.
I heard
I just listened to the song you did.
I listened to the song many times.
No, I just listened to the whole soundtrack and then I got addicted. And then I didn't actually listen to it because I listened to the soundtrack. We didn't focus on the actual like.
the active one. Yeah. I'm talking about that. You know that like our story I think was that painted.
I got 70 of them.
I wrote 6 sentences and outline. No, it's just essay. Oh, I went revenue just for that. I was just like, you get a picture?
What happened? It's when you, that took you 30 minutes. How did it take you 30 minutes? I literally came up from the battery. And then one conversation. What happened? Here's the 6 months.
Not yet, hold up, guys. didn't check to see if it's wrong with the worksheet. Give me just a second, the one that I have. All right, so be ready to talk about what you observed. So that we can start to better understand the gas laws. Get on there. Okay, so I do have a worksheet associated with gas law, but I think it makes sense to give it to you after we talk about the law, instead of having you try and figure your way through it. So, we meet on Thursday. It's another ABCDI week. Yeah, placement testing for the incoming sophomores. All right, see you on Thursday. Have a good one. You too.
Yeah. Can I just stay here? It won't last forever. Ignore that it's crystal. I like to use it on my skin. I don't care.
Oh, you put this on your skin?
Yes. Cameron always talks crazy. She's like, I will put any coconut oil but crystal on my skin. It's pretty cool for cooking. I use it on my skin. I feel special. I use it on my skin.
There's moisturizers with coconut oil on it. You don't have to use Crisco.
I like Crisco. Crisco is on sale.
It's only